Start with the oxygen, as low oxygen is the most dangerous thing. Your result is either going to be low, in which case you want to give them some more oxygen, or figure out why they've got low oxygen, or it's going to be high or normal. And you want to look at the pH. If the pH is high, they are alkalotic, and if it's low, they are acidotic. The key is working out why they are acidotic or alkalotic, so to do that you move on and you look at the CO2. CO2 is either going to be high or it's going to be low, and from that you can work out what is causing the acidosis or the alkalosis. CO2, when it dissolves in water, makes carbonic acid, and that means you're going to make your blood more acidic if you've got more CO2 hanging around. So if the CO2 on your blood gas is high, you would expect an acidosis. And if the CO2 is high and you've got an acidosis, you can say there's a respiratory acidosis happening. Likewise, if CO2 is low, you'd expect there to be an alkalosis because there's less acid hanging around, the pH goes up. So if the CO2 is low and their pH is alkalotic, such as someone who is hyperventilating because they're having a panic attack, that means you've got a respiratory alkalosis. That's simple enough. But what do you do if you look at the CO2 and it's high, but then you've got an alkalotic patient, which is the opposite of what you'd expect? This would mean you've got something else causing the alkalosis because the CO2 is high, so that would make them acidotic. So something else must be causing the alkalosis. That means it must be a metabolic alkalosis. Same is true for the opposite. If your CO2 is low, but you've got an acidosis going on, there must be something else causing the acidosis, because with a low CO2, you'd expect an alkalosis. The classic example of this is diabetic ketoacidosis. Someone comes in with ketones causing their acidosis, and they are hyperventilating to try and compensate and try and bring their pH back up again by blowing off lots of CO2. So they will have a metabolic acidosis, and they will be compensating by hyperventilating. So that's how you work out if you've got a respiratory acidosis, a respiratory alkalosis, or a metabolic cause of your alkalosis or acidosis. Finally, you can look at base excess. So what the machine does is it does a clever thing. It takes the sample of blood that you've just put in and it normalizes the temperature and the CO2. It basically removes the CO2 from the equation and then tests the pH. And what it tells you is how much acid would need to be added to the sample of blood you've just put in the machine to make it a normal pH, to make it neutral again. Literally, how much excess base is there going on? So if you've got an alkalotic patient, it's going to be high. There's going to be an excess of base. If you've got an acidotic patient, it's going to be low. They're going to have an excess of acid or a deficiency or a deficit of base. So you sometimes hear people referring to this as base deficit, base excess. It's the same thing. If you've got a metabolic acidosis, then their base excess will be low. And the reason it's a metabolic acidosis or alkalosis is because the machine has taken CO2 out of the equation by normalizing it within the machine itself. So basically, if you look at the base excess, it tells you what metabolic process is going on. If you've got a high base excess, there's a metabolic alkalosis going on, and if you've got a low base excess, there's a metabolic acidosis going on. If we go back to our patient with DKA, let's say for example they've got a metabolic acidosis, but they're hyperventilating so effectively that it means that their pH is actually normal on the blood gas. It doesn't mean they don't have a problem going on, it means they're compensating for it really, really well. So they might have a pH of 7.35 and it may look normal, but if you look at their base excess, you will see that they have a low base excess and they've got a metabolic acidosis going on. They will also have a low CO2 because they're hyperventilating, but the base excess will tell you what metabolic component is going on, and that's why we use base excess.